Hello, geometry students. This is your favorite teacher in the whole wide world. I don't think I need to mention who I am. This is your final exam, brought to you via this video. Wish you the best of luck. There is an answer document. Make sure you put all of your answers on the answer document. Listen to my directions very carefully. Mr. Heppner's got a lot of hints and cues already on your paper. So, without further ado, we will begin. I wish you good luck, Godspeed, and may the force be with each and every one of you. Okay, gang, so for numbers 1 through 6, you got to determine if there's enough information to prove that two triangles congruent. If there is, you got to write the postulate or theorem. Now, here are your postulates and theorems: side, 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 angle, side, or side, angle, side, angle, side, angle, side, angle, angle, side, and hypotenuse leg. So we're going to look at each one of these, and those are your choices. It's like a word bank there, okay? So here's number 1, 2, 3, and 4. We'll shrink it down and get all 6 of them in there. Okay, make sure you really pay attention to ones where they're sharing a side, okay, like these 3 here that I pointed to. All right, so and again, mark angles, mark sides with the tick marks and the arcs to help you. Even label the sides with an A or with an S to know. Also remember, if there's a right angle, there's one of these in particular up here that might have a lot to do with that. Okay? So write your theorem on the answer sheet for 1 through 6. For number 7, all we got to do is set up an equation. We want to find the length of F to J, so that's right here. So what you need to do is set up an equation with this part equal to this part. Okay, so I just set them equal to each other. Solve for x, and then plug x back in here, so it's going to be 4 times whatever you got for x, plus 4. That'll tell you how long segment FJ is. That's what we want to know. Number 8 is the exact same way as number 7. Set them up equal to each other. Okay, solve for x, and then plug him back in right here to find the length of A to B. On number 9, we were to figure out how many lines of symmetry we are dealing with in this shape. Now remember, lines of symmetry would mean if you were to fold one side onto the other. Okay, so how many lines of symmetry would you have? In number 10, they want us to figure out what is RU, the length from R to U. All right, it's one thing that's important to know, that you can set up this part equal to this part, and we know they're equal because you have, that's a segment bisector, and those two guys are equal. So set them equal to each other, find x, then plug him back into this part. 3 times what? Minus 7. That would give you the length. And number 11, yes or no, is this a polygon? Does this meet all the requirements and the criteria to be a polygon? Okay, for number 12 here, okay, we want to figure out the measurement of angle A. So that is this angle right here. How many degrees would he be? Here's a key note Mr. Heppner wrote in here. This quadrilateral equals 360. So you know what 3 of the sides are, you figure out the 4th. In number 13, we want to figure out what is R. All right. The important thing to know is that if this trapezoid, these two guys are equal, that the consecutive angles, means one right after another, they're supplementary. Do you remember what supplementary means? So it would mean Q plus R, together they're going to equal 180 degrees. For number 14, we've given you a little help here. We want to figure out what's the length of EF. So to get that, you're going to take AB plus DC, divide it by 2. So take those, add them, divide by 2. In number 15, scrolling on down, again, a little helpful hint here. It's one big long equation, but you got lots of like terms, okay, there that you can combine together and then solve for x. And the value of x, then what you want to do is take x and plug it back in here, add the 48 to it. That'll give you how many degrees this angle here is. 16. Again, we're wanting to find x. This is just like number, what number was it? Just up here. Just like number 14. 16 and 14 identical to each other. Now number 17 is a little bit of the reverse order. And so we kind of got it set up for you here a little bit. Because you take these two sides, you add them together, you divide by 2 to get this guy here. Alright? But so this base and this base added together, that's 7.3 plus z divided by 2 equals 10.6. You need to solve for z. The first thing I would do would be I'd multiply by 2 to both sides first. But that's just me. What do I know? In number 18, we want to write a ratio in simplest form of the longer side to the shorter side. So longer, whoops, need a pen, Craig. Longer to shorter. That's how we want to set up. Mr. Hebner wrote a little example here of a ratio, like 24 to 8, and then you reduce it. That'd be 3 to 1. So in your calculator, what you would do is you just put in 24 over 8 as a fraction. And you could write it like that, or you could write it like he did right here. So longer side to shorter side. Number 19, we're just solving for b. The key here, remember, is to cross multiply. And make sure you take 2. It's like the distributive property. So 2 times b plus 4, it's the whole set. You got to distribute and multiply that 2 by everybody equals whatever 18 times 7 is. I don't have my calculator in front of me. But just solve for b. In number 20, we want to solve for x. So we want to set up a proportion. Okay. So me, I think I'd go long or short over long. So that would mean x over x plus 14 is equal to 6 over 18. Cross multiply each one of those, okay? Don't forget that 6 is going to have to be multiplied by the x and by the 14. All right. Number 21. You want to find the value of c, okay? Here's a tip. Since we know these two guys are equal, these sides are split in half, so this is a bisector, segment bisector. He is just half of the original base. So he's just half of it. Number 22, you got to determine if this is a reduction, an enlargement, or a reduction. Remember, always start the original letters without the little prime symbol there, the little apostrophe. That shows the new symbol. So is this an induction, or enlargement, or a reduction? Now I'm saying it. Corey's probably laughing at me. Here we want to find the value of x. So I always recommend that we go original shape as a proportion over the new shape. So here's the original back here. Okay. So x is going to go over, who's the corresponding side here? Hopefully you're saying 32. Is equal to, now we just pick another side here and they give us 7 and 28. So we got to go again, original over new. And now we can cross multiply and solve for x. Okay, number 24. Alright. We want to figure out the value of x. This guy right here. Now, before we told you what this guy was, I talked about how he was half of this. So what do you do to this to get your x? Number 25. Simplify radical 24. Now, you can just use your calculator. Put in radical 24. I don't care about radical form. You can give me a decimal, and that's okay. 26. Find the length of the hypotenuse. Okay, right triangles and radical form. Again, I don't care about that part. Okay, now Mr. Heppner wrote the Pythagorean theorem over here for you. So maybe let's identify opposite the 90 is always which? A, B, or C? Hopefully you're saying C. And you could say that this is A and this is B. It doesn't really matter. So plug them in and solve for C. 27, we're to find the length of the hypotenuse. But this time you notice we're given, this is a 45, 45, 90 triangle. So Mr. Heppner gave us some good help right here to remember that the hypotenuse is going to be the leg times radical 2. So what's your leg? And put it to radical 2. You can leave it as in radical form, or if you put it as a decimal, I think we'll make sure that that's okay too. 28 and 29 have to do with 30, 60, 90 triangles. Now the help here is to find the short leg, which is always opposite the smallest angle. So that'd be like he'd be the short leg here. X would be the short leg here, smallest angle, opposite of him. You just take the short leg divided by 2. All right. And then you got your long leg times radical 3 equals the short leg. Okay. So use these to help you figure out the value of X. Okay, now back up a second here. We made a small mistake in our helpful hint. The short leg, you multiply it by 2. So that's a dot. Short leg times 2 equals the hypotenuse. Okay? So for example here, since this X is opposite to 30, he would be the short leg. Once we figure out what he is, all right, you would multiply him by 2 to get the hypotenuse. Now here you don't need that. So to get the short leg, all right, you're going to need to take the hypotenuse and divide it by 2. But you need to know what he is. So what I would do is I'd take my long leg times radical 3, get my short leg. All right, that's how you get your short leg here. Then in the hypotenuse over here, okay, take your short leg opposite to 30 degrees, multiply it by 2. That'll give you your X. Sorry about that. We have a small mistake there. Corey, quit laughing. Number 30. Evaluate the tangent of 70. Just put it in your calculator. 4 decimal places. Same way with 31. Sine of 27. 4 decimal places, please. And number 32 is the exact same way. Cosine of 45. Write that to 4 decimals. Now, on the next handful of problems, 33, 34, 35, 36, we've already, Mr. Heppner, we've already put on what you're going to need for each one of these problems, okay? And we've went ahead and labeled O, A, and H on all of these, okay? So use these labelings and what has been given to you to find what is being looked for. Okay, they just want you to put a fraction in simplest form. So reduce it. 37 and 38, they're wanting you to approximate these values to the nearest 10th degree. So it means like 7.1 decimal place. So you need to do the inverse of sine and the inverse of cosine in your calculator. 39, again, we've given you the trig functions that you need. All right, it says find of A. Well, so A is your reference angle, okay? So that means this is your opposite, this is your adjacent, of course, this is your hypotenuse, because he's opposite the 90-degree angle. So figure out what the measurement of how many degrees this is. Here on 40, it's another trig. Let's label our sides. Find for measurement of B. So here's your reference angle. It means he's the opposite now. He's the adjacent, and he's the hypotenuse. And of course, here are your three trig functions. Finding a, we just want to use Pythagorean theorem on this one. Okay, here's your Pythagorean theorem. Make sure you label your sides. C is always opposite the hypotenuse, or opposite the 90. A and B don't really matter at all. You could flop them around. He could be A and he could be B. I don't care. Should get the same thing. 42, we're wanting to find the value of R, which would be a radius to the nearest tenth. You're going to use Pythagorean theorem here. That's been written for you. So I would call him side A. This would be C. This would be B. So plug it into the Pythagorean theorem. 43, we want to find the value of x. Well, you can take this part here, the x minus 3, and set him equal to 17, and that will give you the value of x. Number 44, we want to figure out how many degrees this one whole big arc is here. Okay, remember the rule, if it's this angle is all the way on the other side, x is twice that amount, right? So that's how you got to find that. Again, now here find the value of x slightly different. Okay, when it's inside, like this, they're what to each other? Okay, we don't even really need to worry about this so much on this one. Actually, yes you do, I'm sorry. You do, because these are different. So follow the helpful hint Mr. Hepner gave you. So you take AB plus CD divided by 2. That'll give you what that small angle there is. Here to find the value of x, you're just going to take 10 times x, so that'd be 10x, is equal to whatever 15 times 4 is, and solve for x. On number 47, we want to find the length of A to F. So that's this arc right about here. Now, this one we're going to need to use this setup right here. So your arc, which we don't know that, so that's going to be my x, over 2 times pi times, what's my radius? It's 8 feet, is equal to the angle, which is 68 over 360. Okay? I'd first multiply these together first and then rewrite this whole problem, then cross multiply. Okay? If you need any help, let us know. Here's number 47. We want to find the value of x. All you got to do is set these two people equal to one another. Set them equal to each other and solve for x. And number 49, again, being that these are perpendicular lines, these two arcs are equal to one another, so say 3x minus 5 equals 70, solve for x. And lastly, the final question of your exam. I know you're so upset about this. I am too. Because there's nothing better than a test on Monday or Tuesday or Wednesday or Thursday or Friday. Saturdays and Sundays would be even better if we could do it. So here we go. The last question. You want to figure out the value of x right here. Follow this. Take DC plus AB. So you're going to have 83 plus x divided by 2 equals 107. And solve for x. If you have any questions, be sure to let us know. It's been nice doing this for you this year. Hope you've enjoyed it. Hopefully it's helped. God bless.